Second question is example 2. Calculate the quantity of heat. Calculate the quantity of heat required to raise the temperature of a mass of 800 grams of aluminum from 20 degrees Celsius to 75 degrees Celsius. So specific heat capacity of aluminum is equals to 900 joule per kg per Kelvin. I can say per degree Celsius or per Kelvin. So anyway, so here now, so this is the question. Calculate the quantity of heat required to raise the temperature of a mass of 800 grams of aluminum from 20 degrees Celsius to 75 degrees Celsius. So specific heat capacity of aluminum is 900 joules per kg per Kelvin. So now, remember we said this can be in Kelvin or degrees Celsius. Anyway, now this is going to be the solution to this problem. Remember we said, let's just write the parameters out. It's going to be very simple. And I must know what they're asking me to do. So from there, I can bring out my parameters now. So calculate the quantity of it. Calculate what? Quantity of it. So it means my Q is equals to, I don't know, because they did not give me, they asked me to calculate the quantity of it. So the thing is that you must know that you have this parameter, because they say calculate, otherwise your parameter is not going to be complete. So quantity of it required to raise the temperature of a mass of 800 grams. Wow, this is the mass, 800 grams. So I'm going to say mass is equals to 800 what? Grams. Well, this is 800 grams. Well, I'm not satisfied with grams, because we should know the proper unit, which is kilogram. So I'm going to change this what? Gram to kilogram by dividing it by 1000. So I'm going to say my mass is going to be 800 divided by 1000. But for me, you can decide to say, okay, 20 cancel 20. I'm going to say 0.8 kilogram. I don't want to do it like that for now. So I know this is kg, right? This is the kg, but I don't want to do it like that. You can actually do it like that, since I'm going to be using calculator to solve, but I'm going to be using my head. So I want to be cancelling out some zeros, and I don't want to do it like that. So anyway, it's okay. I can actually cancel from here and have 8/10 kilogram. So anyway, let me leave it like this. So what else did they give me? Temperature rise, which is delta T, is equals to 20 and 75. So I'm going to say 75 minus 20. So my temperature rise is going to be equals to what? It's going to be 55. So 55 degrees Celsius. So that is my temperature rise. Now, what again? They gave me the specific heat capacity. So I'm going to say C is equals to 900 joule per kg per Kelvin. Good. I know what I'm going to apply. I know the formula now, which is Q is equals to MC dt. So which is going to be mass. What is my mass? So I'm going to say 800 over 1000 times, what is my C? It's actually 900 times, what is my temperature rise, which is going to be 55, right? So here I can say 20 cancel 20 here, so 10 cancel 10 here, right? Good. So the next thing is to multiply what I have left. So I'm having 8 times 9, so 8 times 9 is going to give us 72, right? So 72, so that's going to be 7 2, 8 times 90 is going to be 720, like that, times 55. Now I can decide to multiply this, maybe like this. So 5 times 0 is going to give me 0. 5 times 2 is 10. 0 means 1. 5 times 7 is 35 plus this is going to give me 36. So 5 times 0 is still going to give me 0. 5 times 2 is going to give me 10. So I'm going to write 0 and keep 1. So 5 times 7 is 35 plus 1. That is 36, right? So I'm going to have this 00693. Wow. So this is my answer. 3960. Now 39600 joule. That is the answer. Now I can put this in kilojoule by dividing it by 1000. So I'll say 1 2 3. So and that's going to be 39.6 kilojoule. And if you like, you can put this in what? You can put this in standard form. So that is the solution to this question. That is the solution to this question. So we're going to solve the final question that I have. Then I'm going to write the other questions on the board, like practice question. They are going to, for you, practice question. Then I'm going to solve those questions in my next video. Now, the last question is this. Example 3. The question says, a copper rod with its capacity 585 joule per Kelvin is heated until its temperature changes from 35 degrees Celsius to 80 degrees Celsius. Calculate the quantity of heat supplied to the rod. If the specific heat capacity of copper is 390 joule per kg per Kelvin, then find the mass. So this is the question. This is the next question. A copper rod with its capacity 585 joules per Kelvin is heated until its temperature changes from 35 degrees Celsius to 80 degrees Celsius. Calculate the quantity of heat supplied to the rod. If the specific heat capacity of copper is 390 joules per Kelvin per kg per Kelvin, find the mass. That is, we have to find the mass of copper. Now, we're going to do this the same way. That is, we're going to bring out all our parameters, and then both what it asks us to find, we're going to bring everything out, and we're going to calculate them one after the other. Remember here, okay, let's do that. So the solution is going to go this way. Here, a copper rod with its capacity 585 joule per Kelvin. Remember, this is not specific heat capacity. This is heat capacity. So I'm going to say 585. Okay, so I'm going to say my heat capacity, which is Cp, C subscript P. This is the symbol for heat capacity or thermal capacity is equals to 585 joule per Kelvin. Now, it's heated until its temperature changes from 35 degrees Celsius to 80 degrees Celsius. So my delta T is going to be equals to what? It's going to be equals to 80 minus 35, right? So this is going to give me what? It's going to give me 45 degrees Celsius. So that is the change in temperature. So we are here, right? Calculate the quantity of heat supplied to the rod. So we are going to calculate Q now. The question asks us to calculate Q. That's the first thing. Now, that stops here. If the specific heat capacity of copper is 390 joules per Kelvin, per kilogram per Kelvin, find the mass. So they gave us specific heat capacity of copper, which is 390 joule per Kelvin, per kg per Kelvin. Now find the mass. Find the mass. So mass, also they asked us to find mass. So M, the mass. I wasn't given the mass. They asked us to find the mass. So what do we apply first? They asked us to calculate Q first. That was the first thing. Calculate the quantity of heat supplied. So now, if I want to calculate the Q, I'm going to say Q. Now, the thing is, we have two formula. Q is equals to MC delta T, right? And we also have the thermal capacity times temperature rise. That was the formula we derived the other time. Now, you know that here I was given the thermal capacity and I know the temperature rise. So I can use that instead of MC delta T. So what I'm saying is that Q is equals to M is equals to CP delta T. This is because this CP is what? Is thermal capacity or heat capacity, and it is MC. So same thing as MC delta T. So but since I was given CP, I don't need to put MC again. And I don't even know M. Now, I don't even know M. So I can't be calculating. I can't be looking for two things at the same time. So what I'm going to do now is that I'm going to use this. So my Q can be calculated like this. CP is 585 times, what is this? That's 45. Now we can multiply this. So that's going to give us 585 times 45. We can multiply those. So 5 times 5 is 25. So 5 remain the 2. 5 times 8 is what? 40 plus this 42, right? So I'm going to write 2. It's going to remain 4. So 5 times 5 is 25 plus 4, that's going to be 29. So 4 times 5 is what? Is 20. So I'm going to say 0 in the 2. So 4 times 8 is 32 plus 2, 36. It's going to be 6 in the 3. So 4 times 5 is 20. So 20 plus this, that's 23. So I'm going to have something like this. 5, 2. Here I'm going to have 15. So 5. Here it's going to remain 1. So it's going to be 6. And it's going to be 2. So 26525. So I have my Q 26525. So my Q is actually equals to 26525 what? Joule. You understand? I can also put it in kilojoule. I can put it in kilojoule to be, my Q is equals to, that's divided by 1000, 1, 2, 3. So that's going to be 26.525 kilojoule. So that is the first thing the question asks us to calculate. Question asks us to calculate the heat, the quantity of heat supplied, and we know we can use this, right? We substitute that, and then we multiply this, and we got this, and we put it in kilojoule by dividing it by 1000. So that is that. Now we need to calculate the mass. The question asks us to calculate the mass, and remember, the question asks us to calculate the mass. Now let us figure out how we can calculate the mass. Now there are two things here. Is either you use the formula for thermal capacity, that is the heat capacity, to calculate your mass. In thermal capacity you have C subscript P is equals to MC. That is the normal formula of this. So, and since mass is inside this formula, and you already have your Cp, and you now have the specific heat capacity here. So you just need to use this formula again. You can use this formula Cp equals to MC to calculate your mass. Or you can use Q equals to MC delta T. Since you know your Q now, you've calculated your Q, but that's just a long way, you understand? So you calculated your Q, you use the Q, you need your M now, and you know your specific heat capacity, which is here, and then delta T, you know it. So you can choose to use anyone. But here I'm going to use this to calculate this. So here, my Cp is known already. So my Cp is what? My Cp is 585. So I'm going to substitute that. So I'm going to say, we're trying to manage the space. So we're saying 585 equals to mass times C is actually 390. So we're going to say 390. So our mass, we need M. So we divide both sides by 390. So our mass is going to be equals to 585 divided by 390. Now, I think 3 can go here. So 3 in 5 is going to give us 1. So it remains 2. So in 28, 3 in 28 is going to give us what? 3 times 9 is 27. So I'm going to have 9. So remain the 1, right? So 3 times 5 is 15. So I have 195 divided by 3 in 3 is 1. 3 in 9 is going to give us 3. And here I have 0. So now I think 5 can go here. So I'm going to say 5 here is actually 3. So how many 5 am I going to see here? It's going to be 3. I mean 3. So in 30, it's going to give us 4. It's going to remain 4. So in 45, 5 in 45 is what? 9. Then divided by 5 in 13 is going to give us 2. So in 30 is going to give us what? It's going to give us 6, I think. So, and then how many? I think how many 26 are we going to see in 39? That's going to give us 1. And then we are going to, it's going to remain 13. So that 13 that is remaining, you know, that 13 that is remaining, that's, you're going to add your decimal points, and you add 0 to it. So how many 26 are you going to see in 130? It's going to be 5. So 26, 5 times 6 is 30, 0 remainder 3. 5 times 2, 10 plus 3, that's 13. So 26 in 130 is going to be 5. So that's 1.5. So our mass is actually 1.5 kilogram. So, and that's is our mass. So remember, you can always use your calculator to avoid, going through all of this stress. You understand? So, and that is that. So the next thing we're going to do now is I'm going to write those practice questions on the board, and then you're going to attempt those questions. So in my next video, I'm going to try to solve those questions. Now, this is the question. When two objects P and Q are supplied with the same quantity of heat, the temperature change in P is observed to be twice that of Q. The mass of P is half that of Q. The ratio of the specific heat capacity of P to Q is what? So that is the first question. So this is the second question. The temperature of a piece of metal of mass 9 grams is raised from 10 degrees Celsius to 110 degrees Celsius when it absorbs 108 joules of heat energy. Determine the specific heat capacity of the metal in joules per kg per Kelvin. So that is the second question. Now, this is the last question. 500 grams of water is heated so that its temperature rises from 30 degrees Celsius to 70 degrees Celsius in 7 minutes. Calculate the heat supplied per minute. So let us try these questions out. So in my next video, I'm going to bring the solution. I'm going to solve the questions so that you're going to see the solution to the questions. So you can drop your answer in the comments. Thank you.